Thank you very much, and it's a great pleasure to be here in your midst, in the sustainability transitions community, which I've always heard is a very, closed community. So I'm really happy that I'm invited to give a keynote to you. I'm an innovation studies researcher, chemist by background, and my main field of research is on the technology mechanism, the role of innovation and technology in the UNFCCC particularly. That's also what my thesis was on, my PhD thesis was on, and that's been my sort of publication record over the past years. And I'd like to really give a lecture on that, but over the past 2 years, I really haven't been able to do much about that because I've been working on this 1.5 degrees report for the IPCC. So I thought what I'd do is give an overview of what that report says in terms of main messages, but also link it to the sustainability transitions community to see how exactly the conclusions of your community have, at least we try to incorporate in this report, and also looking forward to the 6th assessment report, what your community could contribute and what would be ways to do that. So first I'll say something about what the IPCC is, how it works, and why this special report on 1.5C was written. Then I'll give a little bit around the conclusions of the report, how it was structured around the sustainability transitions or systems transitions. I'll talk about the role of the transitions literature and then how you guys could be even more policy relevant through the IPCC. So the 1.5 degrees report, it all started with the Paris Agreement, December 2015, which, as I'm sure you all know, said that we collectively should limit global warming to well below 2 degrees centigrade by 2100 and make efforts to limit warming to 1.5 degrees. And this 1.5 degrees was really a big victory for the small islands, development states particularly, that pushed for that very strongly and successfully. Because basically they tend to lose a lot when temperatures rise to above that. They basically tend to lose their land. Now, in advance of the COP21, the Paris Climate Summit, countries submitted their, at that point, intended nationally determined contributions. Now they're called NDCs. And already in Paris, it was noted that collectively these NDCs do not add up to the emission reduction that we need in order to reach the Paris Agreement goals, essentially. Also, at that point, it's hard to imagine now, but at that point, the whole discussion was about how do we limit warming to 2 degrees. The AR5 had just come out, the 5th assessment report, and there really the discussion among integrated assessment modelers was like, can we still limit warming to 2 degrees? Will the models solve for this? And then suddenly it was basically a big surprise, I think, to the community. This Paris Agreement came up with this 1.5 degree target, and everybody suddenly had to come back to their models and say, okay, can we actually model 1.5 degrees? I always conclude from this so far from the viewpoint of science policy interface of science speaking truth to power. Sometimes power speaks back to science. Anyway, because there was so little assessment of this 1.5 degree target, the parties in the UNFCCC invited the IPCC to write a special report on limiting warming to 1.5C, and the IPCC took up that challenge. We got a deadline, November 2018, when COP24 would happen in Katowice, and that's the first time that the parties would have a dialogue, the Talanoa dialogue, about whether the Paris Agreement goals would be achieved or whether they're on track. Now, IPCC itself is an intergovernmental organization. It's governed by a members' meeting, and the members are countries. So they meet in a big room, and basically the outline, the determination of an outline of an IPCC report is a negotiation. It's countries having different interests and trying to put them in the report. So how does it work? First of all, the big rule of IPCC is that all reports should be based on peer-reviewed literature. So as little as possible on grey literature, that means reports and everything. So we really look at peer-reviewed papers. And the second rule, which I sort of went to bed with and got up with, was that IPCC reports should be policy relevant but not policy prescriptive. So we're supposed to assess the science, also the science about policy, but we cannot make recommendations on policy. So that leads to sentences like, if you want to limit warming to 1.5 C, you should, but we cannot say you should without that qualification. So how it works basically is that, if you start up there's a scoping meeting by authors, and now a few of you here were in that scoping meeting for this report. An outline is produced, it's approved by the governments in the IPCC. And that outline is basically a chapter outline, in this case 5 chapters, and a list of bullets that we have to address as authors in the report. After that, the authors are nominated by their respective countries, selected, and the first lead author meeting takes place. That's that first star. We write an internal draft that's reviewed internally, and with that in mind, we write a second draft after, it's called the first order draft, after the second lead author meeting. And that goes into expert review, and you can all register as expert reviewers. So I definitely encourage you to do that for the 6th assessment report. You actually have a lot of influence when you do that. So in the case of, for instance, my chapter, you get a lot of comments in this expert review, and we got 3,000 comments on chapter 4. It's the chapter on implementation, essentially, alone. And the rule of IPCC is that we have to address every single comment, and both the comments and the responses will be made public. So we even have to be polite. And actually, so would the reviewers be, but they're not always there. So after those 3,000 comments, we go back to the chapter, of course, we revise it, we try to shorten it again, because, of course, if after you get 3,000 comments, your draft is 50% longer. And then we make a second order draft. That goes into expert review and government review. So also governments start commenting then. Then we got 4,400 comments on my chapter alone. After that, we revise the chapter again. We have a final draft of the report. So that means the chapters are basically done. But in addition to that, a summary for policymakers is written. And that's a very interesting document, actually. I always think that the IPCC design is really very clever, because it really organizes the science in the report, and it organizes sort of the politics, the policy relevant stuff in the summary for policymakers. So the report is the domain of the authors. The governments cannot really touch that. They can review it, they can give their views, but the authors have the final say on that. The summary for policymakers is approved in a line-by-line process by all governments associated with the IPCC. So that's essentially, the governments can do a lot with that summary for policymakers, and they do revise it quite a bit. But there's one rule, and that's that the summary for policymakers cannot contradict the underlying report. So also we as authors, we go along to the approval session, which is essentially a big UN type of setting. And if our sort of paragraphs are being discussed and they're revising the text in such a way that they're contradicting the underlying report, we as authors should say, well, no, sorry, this is not in line with the literature, this is not in line with the underlying report, so we have to think of another text. So that's an interesting process, as you can imagine. And then after that summary for policymakers is approved, the report is also accepted, and that's when it gets published. And that, in the case of this report, that was October 8th last year. So this is what these comments look like. They're essentially a huge, that's how we see them, basically a huge Excel file. This was the government and expert review, because you see some governmental comments there. This is on the executive summary of my chapter, and you get comments, everything from, remove this comma, to add this reference, to you're doing a shitty job, assessing the role of banks in 1.5 C worlds or something. So it's very diverse. And also, if you become an expert reviewer, the most useful comments are the ones where you provide peer-reviewed references. And this is what the approval session looks like. This was in Korea last October. It's basically a big room, and you see on the screens, we project the text, the revised text of the summary for policymakers. Up on the podium are usually the co-chairs managing the session, and also a couple of authors that are involved in those sections. And for the rest, there are a lot of governments, and also in the back row, some NGOs or other observers that are looking at how the process is proceeding. Obviously, it's very hard to agree on a text with a couple of hundred people in a room. especially if the text is quite controversial sometimes. So if agreement is not reached quickly, we break out into a contact group or a huddle and sort of have discussions in a small group, try to agree on a text, then it gets back to the plenary and gets approved. This takes days and nights. So the last session, I think, started on Friday night at 7:30 and ended the next day at 3 p.m. And you can imagine that it's, at some point, exhaustion starts playing a role, both with the delegates and with the authors. Okay, then to the content of the report, just a couple of numbers on this report: 91 authors, 40 countries, more than 130 contributing authors that contribute like a small piece of text or a box or a figure. We assessed 6,000. We have 6,000 unique references in the report. Of course, we looked at many more, but because of time and page limitations, particularly, we had to remove a lot of them. More than 1,100 reviewers, including the governments, and 42,001 comments were addressed. I don't know who submitted that one comment, but... So the key messages of the report, now the serious part. We are already at 1 degree of warming globally. And at the current rate, if we proceed at this pace, we will exceed 1.5 C somewhere between 2030 and 2052, so roughly around 2040, so in 20 years from now. We conclude in the report that there are very clear benefits to limiting warming to 1.5 C, and I'll say a bit more about that in a minute. But importantly, we can still limit warming to 1.5 C, but this requires unprecedented changes. And with unprecedented, we qualify that conclusion a little bit. It is unprecedented at the scale and the spread that is needed, but it's not unprecedented in terms of speed. So we have seen individual, and that's also thanks to your community, individual technology transitions that have gone fast enough that what we need for this for these types of pathways, but not at the scale or the spread that we needed. If we wait for the implementation of the nationally determined contributions in the Paris Agreement, which have as a deadline 2030, we will exceed 1.5 C. So this is a clear message to the parties in the UNFCCC that the ambition for these NDCs needs to be enhanced. And finally, limiting warming to 1.5 C would go hand in hand with many other societal goals, including the SDGs. I'll say a little bit more about that as well. So if you forget everything I said, please remember these messages. So why do we conclude that limiting warming to 1.5 C compared to 2, because that was the mandate we got in the report, has clear benefits? An example is that at 2 degrees of warming, we will lose all warm water coral reefs. At 1.5 C, still 10 to 30% would be left. At 2 degrees, the sea level rise would be 10 centimeters more than at 1.5 degrees. And this difference would be stronger if you look at longer timescales. So we're looking at roughly a meter or so, and 10 centimeters on a world average actually makes a lot of difference for some areas. But there's more to this, and that is that between 1.5 and 2 C, it is the estimate that there is the sort of tipping point between irreversible melting of land ice in the polar regions. And if that would happen, that would have much more sea level rise than what we would see just from thermal expansion. For my own country, the Netherlands, it could mean up to 2 meters sea level rise already by 2100. And we're very good at building dikes, but not that good. Other consequences are stronger hurricanes, more forest fires and droughts. And for the North Pole, for instance, at 2 degrees, every 10 years there would be a completely ice-free North Pole, so that's only sea ice. At 1.5 degrees, this would happen every 100 years. And if you look at the sort of the human costs, in 2050 already, hundreds of millions of people, fewer, would be at risk if we would be on a 1.5 degree pathway compared to a 2 degree pathway. And this risk could mean anything from very severe risks of death or migration to sort of a flooded cellar or something like that. So it's a very uncertain and diverse number, but this is roughly what we came up with. So this is why we conclude there are clear benefits to limiting warming to 1.5C compared to 2. Now, how do we get there? If you look at the pathways in terms of emissions that we'd have to follow, by 2030, compared to 2010, we would have to reduce global CO2 emissions by 45%. Of course, there's uncertainty margins there, but that's the sort of the best estimate number. For 2 degrees, this would also be ambitious, 25%, but it would definitely be a lot stronger for 1.5 degrees. And in terms of when we would have to reach net zero CO2 emissions for 1.5 degree scenarios, we're looking at 2050 on a global level, so not in individual or rich countries. For 2 degrees, that would be 2070. And this is only for CO2. If you look at the non-CO2 greenhouse gases, which obviously are also very important, those are already, for 2 degree scenarios, we're already reducing those to the max, essentially. So for 1.5 degree scenarios, you can't do more than the max, so that's basically the same scenario. So the difference between 1.5 and 2 is really in CO2 emissions, and we have to also reduce those non-CO2 emissions very strongly. So what does that look like in a picture? Here you see the, if you focus on the blue envelope of scenarios, currently, last year, the CO2 emissions were about 42 gigatons of CO2, which is on the y-axis here. In some scenarios, the emissions go up still a little bit and start declining rapidly after that. But you see that basically, on average, around 2050, the line dip below zero, so that's the net zero CO2 emissions, and then go negative, and by quite a bit in many scenarios, in the second half of the century. So that means there's a net carbon dioxide removal from the atmosphere, for instance, through bioenergy and carbon dioxide capture and storage, or through certain land use efforts or direct air capture or those kind of technologies. Not going into those here because of time reasons, but that's a whole field of its own, whether that's feasible or not. Basically, the conclusion here is the quicker you start with reducing emissions, the better your chances that you will not need as many carbon dioxide removal technologies later on, and that you will limit warming to 1.5C. So we're, if you read in the newspaper, we have 12 years left to reduce. That's nowhere in the report. Every year, every ton matters, even now. Of course, these are modeled pathways. We looked, that was in chapter 2 particularly, which is more the modeling work. In chapter 4, so my chapter, we looked at sort of what sort of transitions you would need and how feasible are they and what are conditions enabling those. And we distinguished 4 systems transitions, and we deliberately didn't organize this according to economic sectors like transport or buildings. And the reason was that we, in our chapter, also took into account adaptation. And the mitigation sectors and adaptation sectors don't completely overlap. And we felt that with these 4 system transitions, both could be addressed responsibly. So we're looking at an energy systems transition, obviously, land and ecosystems transitions, urban and infrastructure system transitions, and the industrial system transition. And in addition to that, a lot of carbon dioxide removal, which is necessary. Within these transitions, we identify a number of mitigation and adaptation options, and we set up a methodology to assess their, what we call feasibility, which is, of course, a bit of a tough term. We looked at 6 dimensions of feasibility, as we call them. Environmental, technological, economic and geophysical are probably very commonly addressed, but we also looked at institutional and social-cultural feasibility of 28 mitigation options and 25 adaptation options. Now, of course, this is on a global level because the whole report is on a global level, and we couldn't really say, well, this option is feasible and this is not feasible, obviously, because it's multidimensional. But we could sort of give a first indication of where policymakers could look first for things they could already do and where potentially they would need to invest more in order to increase the feasibility. So all these 6 dimensions, we have like 3 to 5 indicators, and we looked at the underlying literature for the 28 mitigation options and saw whether what sort of the verdict was. And this whole feasibility assessment had 1,500 references or so underpinning them. And this is the sort of the summary table of that. So what you see here is basically, for instance, for solar PV, the darker the color, the more feasible. We have high economic, technological, socio-cultural and environmental feasibility, but still in many areas of the world, institutional and geophysical limitations to the feasibility. For instance, geophysical, not everywhere in the world does your solar PV deliver as much. If the cells here are white, so there's sort of a light color which is low feasibility, but if they're white, there's not enough literature to assess, and especially for carbon dioxide removal options and the social, cultural, and the institutional and economic fields, the literature was very, very limited, so we basically couldn't assess that. Okay, so that's feasibility. Then we also looked at a number of enabling conditions. So what are critical enablers for these system transitions? We distinguished 6, and I realized very much that there's many, many ways that you can cut this cake, right? So these are the 6 that we arrived at. First of all, finance and investments. And we tried to make a quantitative assessment of that, and we got a fairly back-of-envelope assessment of all the savings in the world, of all the investments in the world, we would need an additional 2.5% in order to get on a pathway to 1.5C. So that's a lot of money, but it's also not it's not 20% more global investments. And this is energy, transportation, etc., all mitigation sectors. For adaptation, we could not make an assessment because it's very hard to distinguish adaptation finance from development finance in general. But this additional investment really hides a big shift from fossil fuel to non-fossil fuel, basically, investments and infrastructure. In terms of policy instrumentation, we, as many of you, I think, here in this community are arguing that you cannot do without a policy mix. For example, CO2 pricing can be a useful instrument, but it's not sufficient on its own. What it does is improve efficiency and lead to cleaner production, but it's generally not transformative. And policy instrumentation must also include instrumentation around de-risking investment, so the interaction with the finance sector. Thirdly, and very importantly, and there's not a lot of literature on this, institutional capacity. So we need everywhere in the world, at all different levels, we need to have people who know what they're doing, basically. In order to get on this pathway. And I think this is one of the biggest challenges, because if I'm in my country already, in the Netherlands, it could be more developed, let alone in the global south. Then governance, the ability to cooperate across actors on different levels. Again, the private sector, the public sector, but then also from the local level all the way to the international level. We need behavior change. It's very hard to realize all this if we continue with the lifestyles that we are currently leading, especially in the north. And finally, technological innovation as an important critical enabler. And with that, you have to realize that it takes, 30 years or so for technology to go from basically lab scale to commercialization or implementation. So since we're already almost in 2020, and by 2050 we need to be net zero in terms of CO2 emissions, existing technologies are really important. But also on that you can innovate, obviously, as you all know. Okay, we also looked, I'll keep this very brief, at the interaction between mitigation and adaptation options and the Sustainable Development Goals. And this is a bit of a complicated graph. You can look it up in the report or the summary for policymakers. But basically what this says is that across the board there are more synergies than trade-offs between SDGs and 1.5C mitigation pathways. Although it differs a bit between energy supply, energy demand and land-related mitigation options, and those synergies are generally greatest in the energy demand options. Now, if I summarize how we try to assess these system transitions, so we have 4, right? Energy, etc. They are informed by these pathways that are based on integrated assessment modeling, but that's not the complete assessment we have in the report. We also looked at the feasibility of options across 6 dimensions. We looked at enabling conditions, those other 6 that I just mentioned, and we looked at the interaction with the SDGs. So this is just to summarize the complete framework in the report. Okay, then looking forward to AR6, the 6th assessment report, and some observations on the sustainability transitions community and what you guys could contribute. First of all, the AR6 will, the working group 2, which is impacts and adaptation, and the working group 3, which is mitigation reports, will be published in 2021. And the literature cutoff date, so the deadline by when papers would need to be accepted in journals, is somewhere early 2021. So if you want to be cited in the report, your paper will have to be accepted by that date. Already, I think there's a much bigger involvement of this community in the IPCC than there used to be. I really see a trend in the IPCC from being mainly based on integrated assessment models and techno-economic analysis to having a much more complete picture and taking into account the social sciences. And I think the 1.5 degrees report tried to sort of take the first baby steps towards that, but I think the AR6 will go much further. There's several transition scholars engaged as lead authors in particularly the mitigation report. Frank Gils is a lead author, Benjamin Sovacool is, and probably others. And also there's a chapter 16, which I'm a lead author on innovation, technology development and transfer, which explicitly is there to assess also this kind of literature. And it's also important because in this global stocktake for the Paris Agreement, as you all probably know, in the Paris Agreement there is an article, Article 10, on technology. And also the stocktake will have to involve how things are proceeding on technology. And I think for that, this community could give some input. And that's also why this chapter is there. So you can look at where the transition scholars are here. This is the group of authors for the mitigation report. I think there's some under-researched topic in the AR6 that you could consider focusing on in the next year and a half or so. First of all, the interaction between mitigation and adaptation. I think in the 1.5 degrees report, we try to take these two together. And I think they increasingly will have to be taken together in terms of a system transitions perspective. But methodologies for that are lacking, I think. It's really tough to assess that in a report. Also, an observation on the sustainability transitions literature, just from trying to assess that literature from the 1.5 degrees report, is that it's basically, and I'm putting this too bluntly, but it's case studies and theories. And we're dealing with huge page limitations. So we don't have a lot of room to assess all the case studies, right? There are just too many of them. And they're too diverse. Also, we want to be policy relevant. We have to be policy relevant. So theorizing is also something that you don't always cite in an IPCC report. I think there's a need to publish studies that give actionable results from those case studies and take it to a next level if you want to be useful for an IPCC assessment report. So meta-studies, potentially on innovation policy, on TIS, especially in the Global South where there's a dearth of literature and we want to be inclusive in IPCC report and including capacity building, which is also part of the global stocktake for the Paris Agreement. And also at this conference I see some very important sectors that are not assessed much in the papers that I've seen here. For instance, the energy-intensive industries, steel, chemicals, which make up 1/3 of global CO2 emissions, aviation, and also international shipping. And I think there are big lock-in, path dependency, etc. challenges in those sectors. Okay, final slide. The way to look, I think, at this, at climate change, at this 1.5 degrees report, is that the world will change anyway. If we don't limit warming to 1.5 C, if we go to 2 degrees or even beyond, the world will look differently. But we still have a choice to what it will look like. And limiting warming to 1.5 C has clear benefits and it's still possible. And besides what we do, how we do it matters, and that matters for the Sustainable Development Goals, and I think that's also a big research topic of your community. So I think you have important insights to bring to policymakers through IPCC reports and through other things. 3 pieces of advice: write actionable, peer-reviewed publications, work on relevant issues that are currently not covered so much in the literature, and become an expert reviewer and comment on the report. Thank you very much.